So number 30? Is that X-Wise or what am I looking? No. This is this is just graphing. Okay. So really, this is a question about how do I change my window on the graphing calculator. So many options. Okay. Here, while this thing is loading, let me give you guys this. Let me go ahead and put this away. This is the practice test, so I'll have the answer key for this next time.
How many questions are going to be in the just 12?
All right. And here's the thing. When you get this, I've had evil teachers that said stuff like, oh, there's only 4 questions on the test, and then each question had parts A through J. Well, that's not 4 questions. So, if you count up all the questions on my test, it's normally somewhere between 25 and 30 questions. You know, adding up A, B, C, D. So here on the practice test, there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 35 on the practice test. And of course, if you want to get really good at basketball, for example, you practice with a slightly bigger ball, and then all of a sudden it's easier. So my practice tests very often are longer and sometimes involve, this one's going to be about the same level as this, but they sometimes involve slightly more difficult problems. So then you can see how it's worked out when I give the answer key. This one's about the right level. So you will definitely see stuff related to this on the test. Cool. This is just, when you do the practice test, I'm going to give you the answer key. Do not think that this helps if you look at my answer key and agree with it. I see that all the time. Yeah? Yeah, I see. I mean, just agreeing with me doing the work, that's nice, but it doesn't get you anywhere, right? So if you're going to do this, do it, and then check the answer key. Maybe even time yourself, because you have to get used to having a time constraint, right? But be careful if you do that. Don't just agree with my answers. So this problem here, number 30, and number 32 is really just the same.
Yeah, just keep doing that.
Thanks, sir. So go to y equals, if you want to play along, and the problem is x squared minus x minus 20. So whenever I put a new function in, I pretty much always hit zoom 6, zoom standard. It brings it back to negative 10 to 10, negative 10 to 10 for both axes. And of course I did zoom bias. So zoom 6. Okay, so that starts off negative 10 to 10. Now, they specifically want me to do, if you look at number 30, it says, make the window for the x's negative 2 to 2, and for the y's negative 5 to 5. That's part A. So if you go to window, you can change it. So right now, that parabola just exists. So I always have this thing in my head, and actually specifically I have the Beatles' Yellow Submarine cartoon in my head. So when you look through the porthole, has anybody ever seen that? Psychedelic Yellow Submarine? Look it up. It's really cool. And of course, if we just turn the submarine, I can look at different things. So the parabola is sitting out there. Right now, I'm looking at negative 10 to 10, negative 10 to 10, and obviously there's a problem with that. It's not good enough. I can tell already. I can't see down here. So if I could just kind of move this window down a bit, I can see the bottom. So that's kind of the idea of why we want to be able to move our window around. So I can see the important points, like the lowest point on that might be important. But they want to specifically start with x's go from negative 2 to 2, y's go from negative 5 to 5. So x min is going to be negative 2. The minimum x is negative 2. And the max x, of course, is 2. The scale here just tells it how many tick marks will it actually put on there. So it's going to put one line every 1, 2, 3. So you can actually make that scale 0.5, and it'll put a tick mark at 0.51, 1.52. You guys see what I'm saying? So if I had like from 500 to negative 500, I don't want one at every 1. Maybe I want one at every 100. So I don't have this crazy, going crazy. So let's just leave that alone. What's y min going to be?
Negative 5.
Good. Negative 5 to 5. So y min will be negative 5. Well, I don't know if anybody's getting this error. If you do this and you get this error, whenever you see go to for an error, that kicks ass because it's going to put the cursor right on top of the problem. My mistake here was I used a minus sign, not a negative sign. Do you see that? We do, Jeff. We just don't want to tell you. Okay. I can deal with that. Don't worry about all the crap at the bottom. Now, so now we got our negative 2 to 2, negative 5 to 5 window. Let's see what it looks like. And of course, part A is going to make it show me nothing. Right? So that's a bad window. So then they say make it negative 10 to 10. That's the one we had first. To make it negative 10, 10, negative 10, 10, you just hit zoom 6. So it always takes it back to that. And that's still not a good window, right? So this is part B. Zoom 6. It's better. I see something. Uh-oh, if it still works. But I can't see, like, the most important point of a parabola normally is the vertex. The very bottom or the very top if it opens down. So still not a good window. So hopefully part C is a better window. You know, and then they ask you which one's the best window. Which one showed you what's going on the best. Is that cool? Yes. All right. You guys are scared. All right, cool. But if I just saw this, and I didn't have a book to help me figure this out, what do I really want to change to see what I want to see? Yeah, what do I want to change up here? Maybe make it what? Negative 20? Sure. Almost. And see how the little tick marks are getting a little crazy? Right, so if I got a window, I can change, I need to go just a little bit further down, and then I can make my Y scale maybe 5. So it'll put a tick mark every 5. So it's not going crazy here. And there you go, now I can see my little vertex. Yay. Is that cool? So you will, of course, when you graph a function, it has no reason to be in the window you've got currently. You might have to change a window to see what's going on. There's also this, which sometimes sucks. Let's see what it does. There's zoom. Holy crap, there's more than I remember. There's zoom. You used to be able to just go to the bottom, and there was zoom fit. Zoom fit. If you hit that, it's supposed to try to fit everything you might want to see in there. And sometimes it does right, and sometimes it really sucks. So it's good to know how to use a window. You guys sort of... Of course, you also have zoom out and zoom in, and sometimes that's too simplistic. You zoom out, and the whole thing just disappeared. Oh shit, that's too big of a step. So that's why you're able to control your window more specifically. Okay, maybe. Okay. You'll notice on the practice test number 4 is a problem that you have to use your graphing calculator. I'm going to have at least 1, if not 2, problems where you must use your graphing calculator. I will have some you can borrow if yours dies or if you don't have one yet. If you don't have one yet, get one. You can check them out in the library also, if they have some. Yeah.
I have a question on number 53 on section 2.3.
This is page 171, 53. This another one's got the little graphing calculator symbol next to it, so you have to use this graphing calculator. Blah, blah, blah. So a highway engineer wants to estimate the maximum number of cars that can safely travel a particular highway at a given speed. She assumes that each car is 17 feet long, travels at speed S. So S is speed.
Actually, it was 54.
Man!
Sorry,
I was getting into that one. All right, 54. Between 0 and 30 degrees Celsius, the volume of 1 kilogram of water is given by this formula. I'm not going to write it out. There it is. Find the temperature at which the volume of 1 kilogram of water is a minimum. So it's really neat. Between 0 degrees and 30 degrees. And of course, what happens at 0? It becomes ice, and of course the volume increases. You know, when it becomes ice. If you ever put a Pepsi in the freezer and forgot it, and then it's busting at the seams, have you ever done that? Yeah. Some of you guys are like, no, let me try. So they want you to use a calculator because this is not even a parabola. It's disgusting. What degree is it? 3rd degree equation. So if you plug this into your calculator, 999.87 minus, and they use T, but the variable doesn't really, did I leave somewhere on? 06426 X. Who cares what variable you use? Plus 0.008 504 3x squared minus 0.00 679 x to the, there's your to the button, in case you're curious, to the 3rd power. If I hit graph right now, it's probably going to be freaky or nothing. Let's see what happens. Because remember, I got my window all changed. So if I go to zoom 6, let's see if I see anything. And of course, I kind of know what's going to happen. Now, can anybody help me out? What part of this problem tells me where I should put my window?
Right, you could use zoom table.
Holy crap, look at all that stuff I'm showing.
Wow.
Yeah, you could go to the table, but actually, if you just look at your equation for a second, the y-intercept is almost 1,000. Do you guys see that? If you make x 0, don't you get this number here? So it starts at 1,000 and it kind of goes away from there. So I've got to be able to look up around 1,000. So I got to go to my window. And what exactly do I want to change here? For which variable?
X and Y.
Just the y, because that's going to control up and down. So if I make my y go around 1,000, let's make it 950 to 1,050. Why did I do that? Do I have some secret? No, I don't know. Just made it around 1,000. I don't know yet. I can see it. Yay! It's not really doing much. Oh.
The scale was still on 1.
See?
The scale was still
Yeah, so you can see how it's crazy. Stacked up. Something that's really a big clue is they give me that, what is my temperature supposed to be between?
0.
So I can go back to my window and make x 0 to 30. And now look, it's going to be very blah. Okay. Not very good, right? So what's still kind of wrong? I went around 1,000. Why can't I really see a lot of variation here, do you think?
Right.
The Y scale.
The y scale is a little too big. So I want to kind of, right, I don't have good resolution here. If I could just zoom into like right here, then I can see better what it's doing. So if I made my window maybe 980 to 1,020. That would be a little bit better. Of course, I want to be even more in there. That's a little bit better. So make my window 995 to 1,005. Let's see what that does for me. There we go. Look at that. Now, see, I didn't see that little dip before until now. You guys semi with me? I mean, if I zoom out too much, then it's going to look like a straight line. I can't see the variation well, so you have to just make it come in a little bit, right? Make your Y min and Y max a little bit less so that you actually just zoom in on that piece of it. Now I can see that dip. Because the whole question is, find the temperature where it's a minimum volume. And now I can see where the minimum would be. How the hell do I find that exact position? Yeah, exactly. You go to the same place where you go to find intersections. Anytime you have to find some place on a graph that does something specific, you go to second trace to get up into calc. Now, if you can't see which one to use, I can't do much for you. Which one do I use? The minimum. There. All right, good. So I want to find the minimum. Thank God they call the damn thing minimum. That makes it pretty easy. So it's going to ask me, now where is the minimum? It's about right... Get over there. All right, it's going to take a while. Keep going. The minimum's about right there, right? You guys with me? So it says left bound. So I'm going to go left a little bit. Enter. Then it says right bound. I'm going to go right a little bit. Enter. And then it says guess. So then I'm going to put it right about where I think it is. Enter. There you go. So it's a minimum about right there, about 4 degrees almost. You guys semi with me? If anyone's taking any chemistry, this is actually a fact that you talk about. The temperature at which the volume of water is the least. So you're like, all right, whatever. But the most important thing to get here is not the specific function. It's not learning chemistry in math class. It's, if I give you a function, can you find the minimum or the maximum? Hell yes, you can, right? You go to min. And it's going to say left bound, so you go a little bit left of the answer, right bound, you go a little bit right of the answer. It just gives it an area to search in, and you put the cursor on a good guess, and then it gets it.
And that's the answer.
And that's the answer. That 3.96, whatever the hell it was. Enter for the left bound. Enter for the right bound. I guess. So 3.97, you want to round it? So about 3.97 degrees Celsius, that's when water has its minimum volume. Because when you heat it up, it of course expands. When you cool it down, water actually expands also, right? So it's right in that 0 to, around 4 degrees where it's a minimum volume. Yeah.
I have another question on section 2.4, number 18.
Oh yeah, good. This one's a little bit freaky. This is page 177, number 18. Okay, so in general, if I want to know the average rate of change from x equals a to x equals b, so I have some function doing some weird stuff. I want to know what's the average rate of change from a to b. What's its average rate of change? It's just the slope formula. So it's the y2 minus y1 over x2 minus x1. It's just the slope formula. And actually, this is where we start. In calculus, we just take the next step. And actually, this problem, number 18, sort of in that direction. So what if I say the function I'm working with is 2 over x plus 1. And I want to know what's the average rate of change from 0 to h. And we shouldn't be surprised. I mean, at this level, we have to work with variable inputs. Right? We're not always going to get numbers to work with. All right, too bad. So here's an example of one where you have to work with an input of h. So you just use the formula. So I'm going to have to do g of h minus g of 0 over h minus 0. What is g of h?
2 over h plus 1.
And what's g of 0? 2. You got 11. And h minus 0, incredibly enough, is h. Now, the question to me then would probably be, what the hell do I do with this? There's a couple different ways to look at it. Personally, what I would do is kill the internal fraction. You are allowed to multiply if you have two sides to work with, right? You can multiply two sides of an equation. I can multiply the top and bottom of a fraction. So I would directly kill this. Some of you guys might want to make LCD and get those together. That's fine. I would do this. I would just multiply top and bottom by h plus 1. Because won't that kill this? And doesn't that just pick it up? You guys semi with me? So really, this is all about setting it up and then simplification. Can you simplify what you just set up?
What would you do with x squared on the bottom?
Oh, don't worry about that. Watch where this goes. Somebody help me out. What do I get on the top?
2 minus 2h.
Good. Here the h plus 1's cancel, so you get 2. Here, 2 times h plus 1.
2h plus 2.
You got to be careful because that negative's got to go with it. All over h times h plus 1. You just stop right there. You guys semi with me? This is the kind of thing that you should not be afraid to do. Right? We know we can multiply top and bottom fraction by whatever the hell you want to. So if you have fractions inside of fractions, that's the most direct way to make it look better. Kill those internal fractions. Right? And then you hope that God something happens you could do something with. So here you get 2 minus 2h minus 2. That kicks ass. Why does that kick ass? Because the 2's cancel. So you get negative 2h over this. And what's the last thing you can do?
Cancel it.
The h is canceled. Exactly. And that's it. There's a freebie. Take that a little bit further. As far as I can take it, because that's it.
So like the bottom denominator, you don't distribute it?
We'll see how that's not a good idea. Whenever you have a rational expression like this, a ratio of polynomials, you don't multiply things out because you want to see if something cancels.
Okay.
If you multiply this in, you might not notice that the h is going to cancel.
Yeah.
Always leave it in factored form when you have a ratio of stuff. So you can see at the end, does anything go away?
What section is this?
Oh, 2-4, yeah. 2-4, number 18.
Can you do number 27, same section?
Now here, they don't have a function for us to plug stuff in. They actually just give us the points directly. So when they say, what was the average rate of change between 93 and 2003? The years are the inputs, and the sales are the outputs. So you would do Y2 minus Y1.
Okay.
So you would do 584 minus 512. You with me? That's like an XY table now, number 27.
Yeah.
You see the table there after the problem. So you have to look up. Cool. So there's your XY. So actually, when you look at 27, you might be freaked out because you don't know to look up there to see the data. Make sure everybody sees what I'm talking about. Here's. So when you look at 27, you might just look at this and say, what the hell? Alright, there we go. But the data is up here. So when they say what's the average rate of change between 93 and 2003, I just have to find the slope, x, y, just an xy table. So y2 minus y1 over x2 minus x1. So the beautiful thing about average rate of change is another word for slope of the straight line. So take the slope between those 2 points. Okay. Is that cool?
Yeah, and then also number 30.
And this is sort of the same thing. They just give you points on a graph.
It's just a different layout.
So between 1860 and 1890, is that what they say? Yeah. 1860, 70, 80, 90. Just take those points, y2 minus y1 over x2 minus x1, find the slope. Average rate of change. I love it. Okay, cool. All right, one last question. What's up?
Did you do 42 on 2.3?
Oh no, of course it did. I was thinking to myself, hopefully it doesn't need the graphic calculator. It does. Okay. So for this one, you graph it, and when you graph that, let's see, you're probably going to end up with something like, it might be something like that. You're going to try to find the min, right? Don't hold me to that. You're going to try to find the min, and where is it decreasing and increasing? So you're going to use the graphing calculator to help you. If you can see the minimum and the maximum, let's just pretend like it's this. Then in between those two, what's the function doing? Increasing. So if I knew this point was 2.9, comma 4, and I knew this point was 3.8, comma 4.7, on what interval is this increasing? 2.9 to 3.8. Beautiful. Because when I say where is it increasing, what interval on which, that's in terms of x. From x equal to 2.9 to x equal to 3.8, it's increasing. So if you find all the places where it's mins and maxes, in between those must be places it was increasing or decreasing. Because those mins and maxes are also known as turning points. Kind of makes sense. Before that it was increasing and then it was decreasing, or the other way around. If it's a minimum. Does that make sense?
Yes.
So you have to use your graphing calculator because the numbers are probably gross for those mins and maxes. Yeah.
Can you help me afterwards with a problem on the other side?
Sure. Okay. Okay. So we have 2 sections left in chapter 2. One of them is relatively easy, which is nice. And the other one you should have already talked about. You should know the idea of inverse function already. So we'll go over it. The first one, section 2.6, is part of it is exactly what you think it should be. If I said
This is 2.6.
this is 2.6, yeah. What do you think? Let me see if they use this notation. Yeah, they did. Okay. What do you think that might be?
Minus 3 minus 4.
Yeah. So this is just another way to write f of x minus g of x. So it would just do exactly that. It would be
X squared
X squared minus 3 minus 4 over x minus 5. What's the domain of this? Good. X cannot be 5. That would make that go crazy, right? Okay, cool.
That's all you would do?
That's it. That's all I asked for. Right? Find the difference between those two functions, and then I said, what's the domain of that end result? Do one thing for me. I want to make this do something specific. Make that a plus. Is that cool? You'll see why here in a minute. You'll see why here right now. So what would this be here? Let's do H plus G of X. Almost too easy, right? Don't try to go very far with this. You can't simplify it. H plus G. But what's this guy's domain? This is a little bit more difficult. What's this piece's domain?
Has to be greater than
So the domain of H would be the inside has to be greater than or equal to 0. Is that cool?
Yeah.
So really, domain, and I've told several of you guys already today, but the domain is always this. Say the restriction in English, the inside has to be 0 or bigger. And then write that in math. The inside, 0 or bigger. Solve it, you got it. So the x has to be bigger than or equal to -2. What about for the g part? We already did that. X can't be 5. So what's the domain of the whole thing then? That's the pieces parts. What's the domain of the whole thing?
greater than or equal to 2, not 5, or -2.
Yeah, it's greater than or equal to -2, not including 5. Right? Some of you guys might understand why I turned that around now. I want to make sure that I hit that 5 speed bump. So if I wanted to write this out, it would be x greater than or equal to -2, x not equal to 5. That's a little gross. And some of you guys are going to say this is gross, but it's not. The better way to write it is like this, not like that, Jeff. That's a bad way to write it. So from -2 to what? Where do I have to stop?
4.
5. Start over at 5 and go to infinity. So it's -2 to infinity, skipping 5. So if you read the book's explanation, of course when you put two functions together, the domain of the whole thing is going to be dependent on what problems each thing had. Right? This has problems and that has problems. When you combine them, you have all those problems. Right? Think about Thanksgiving when your family gets together. All those problems come together. Or not. I don't know what it's like at your house. Is that cool? Yeah.
So, why is it infinity? Positive infinity?
Oh, because, so this can go up forever. This goes all the way to infinity, and this only has a problem at 5.
Oh, okay.
So it's all the way up to infinity, there's no problem. So this guy would say -2 to infinity. And the other guy says, wait, skip 5.
Oh.
And that, there you go. Yeah.
What is that in the middle that you
Where am I
put?
looking?
Between the, like a little V, between the -2, 5, and your answer.
Oh, this means union. It's another way to say or.
Oh, okay.
Right, that set or the other set, that's where I can get numbers to use. Cool. Okay. That's section 2.6. There's really not much more to it. And we already kind of went over this other part. We went over this at the end of class last time. What do you guys think this would be? What do you got, Jeff? H of f of x. Which actually the book will write like this. H of f of x. You write it better as h of f of x. So what function are you plugging into what function? You're plugging f into h. So you can really just replace f with what it is. x squared minus 3. Now that's got to go
Where the X is.
into h where the x is. I love it. So how would you write that? H of this,
2 plus X squared minus
square root of 2 plus, in place of x,
X squared.
put that business. And then just simplify what you can. And of course the only thing you can really do there is 2 minus 3. Negative 4. Do not go further and say that this is x minus 1. Yay! No. Right? And it's not because you can't do the square root negative, it's because you cannot have a square root go across a subtraction. Right? You guys kind of with me? I saw a few things like that. Square root of 4 plus 9 does not equal 2 plus 3. That should be square root of 13, which is not equal to 5. Right? So square roots do not play well with addition. They won't just distribute like that because square roots are not based on addition. They're not going to do that. So be real careful. Same idea that you can't just make that x minus 1 or something. You can't take the square root of each piece. It doesn't work like that. It can't. Okay. Let me see. Did you throw anything else weird at you? Oh, here's a little bit of weirdness. If you have your book, look on page 196. Number, doesn't really matter. Number 29. So number 29 gives you two functions, but it graphs them. So the blue line is g, the red line is f. 29 says, what's g of f of 4? So what do you have to figure out first to be able to do this problem?
It's f of 4.
Yeah, you always work on the inside out. Order operations pretty much makes us do that. So there it is. Okay, so g of f of 4. So we know we have to work on the inside first. What is f of 4? They didn't give me f of x. How the hell would I know what f of 4 is? Yeah, somebody's already done the work, right? If they give me the graph, they've done the work. F of 4, 3, 4 must be 2, because that's where they put the point. So I don't need the function. They've already done the work. So f of 4 is 2. All right, so put that in there. G of, well, this is 2. All right, now I just find g of 2. What's g of 2?
5 or 6.
2, 3, 4, 5. Cool. And that's it. We sort of talked about this idea by itself before. How to read a graph and see f of 3, f of negative 1, all that kind of stuff. But now this kind of like doubles that up. You have to do the inside and then do the outside function. Is that cool? What about number 31? G of negative 2.
Find g of negative 2.
Yeah, find g of negative 2 is 1. And then g of 1 is 4. I love it. You guys cool with that? In a way, that's nice. Somebody's already done all the work. I just have to go see what they did and use it. It kicks ass. Let that be nice. Okay.
On 29, can you show me how you got 5?
Oh, g of 2. G is blue. So g of 2. So when you have for an input of 2, what's the output for the g function? Where does g go?
Okay.
5. That's how you read it. Cool. Okay. That's basically what this whole section is. Let's see. I'll tell you what. Instead of trying to slam all this in, 2-7's a little bit involved. So you need to talk about 1-to-1 and all that. Give us a break. I don't think you guys will mind too much. So what that means Plus, I'm letting myself get out early too. What that means is this next test will not include section 2.7. You guys with me?
Yeah.
You do not have to do 2.7 homework until test 2. It will be on test 2. We're not skipping 2.7. I'm just moving it to test 2. So on the practice test, this is important. On the practice test, you don't have to worry about 5E. You with me? 5E. I'm not going to ask something like that. Some of you guys might not know what that is yet. 5E and 6F. Oh, and number 10. So those 3 are from section 2.7.
Did you say 5B or 5B?
5E is in every or excellent. Yeah. 5E, 6F, and number 10. So next time I'll have the answer key for this on Monday. Yeah.